All right, the whole point of this video is to introduce you to the cone and its anatomy and teach you how to find lateral area, surface area, and volume of the cone. First things first, what is it? A cone is a geometric figure which has a circular base where the upper surface narrows to a single point called the vertex. We're going to talk a little bit now about how the cone is put together and introduce you to some vocabulary that you'll need as we work through the remainder of this unit. So I'm going to teach you first a little bit about altitude of a cone. The altitude of a cone is going to be the perpendicular distance between its vertex and its base. So the altitude of a cone will always make a right angle there with the base. So in this particular case, the altitude or the height of my cone is represented by the blue line segment. Now in a right cone, the altitude is going to meet the base at the center. So our study of cones this year is only going to be about right cones. So if this cone is a right cone, that tells me that that point where the altitude meets the base is the exact center of our base. All right, slant height is a little bit different than the height of the cone. The height of the cone we said is the distance or the perpendicular distance from the vertex to the base. The slant height is going to be the distance from the vertex to any point on that circle that makes up the base. So in this particular case, the height of our cone is represented by the blue line segment, whereas the slant height of a cone is represented by the green line segment. They're two distinct and unique parts, and you need to be able to tell the difference between the two of them. All right, lateral and surface areas. Just like every other figure that we've studied, the lateral area does not include the area of a base. Just like every other figure that we've studied, the surface area of the cone does include the area of the base. So that's absolutely no different than anything you've seen and done so far in this unit. The formula for finding the lateral area of a cone is a little bit unique. It says the lateral area is equal to pi times r times L, where L represents the slant height of our cone. Surface area, just like the pyramid, is going to be comprised of both the lateral area and the area of only one base. All right, so let the fun begin here. Number one gives us a right cone which has a base radius of 6 and an altitude of 8. They want us to find both the lateral and surface areas of this cone. So in looking at this cone, I'm going to go ahead and label the pieces of the picture or the parts of the cone that I know. Because I'm given that the radius is 6, I can go ahead and label that in my picture. Because we're told that the altitude or the height is 8, I'm okay to go ahead and label that in our picture. Now I'm going to go ahead and get started. Lateral area is pi times the radius of our cone times the slant height of our cone. 8 represents the height. We need the slant height. So in order to find the length of that red line segment that represents the slant height, I'm going to go ahead and do a little bit of Pythagorean theorem action. So our slant height in this picture is equal to 10. So now I'm all set to go ahead and substitute into my formula over here. And then I need to decide what to do with all these factors or numbers that I have on the right-hand side of the equation. Do I put them all into my calculator? Do I put everything except the pi into the calculator? Well, if I go back up into the problem and look, nowhere in this problem does it tell me to round. Because I'm not being asked to round, I know that my answer needs to have a pi in it. So I'm going to go ahead and I'm going to multiply the 6 times the 10, but I'm going to keep the pi. So 6 times 10 is 60. I did not yet multiply by the pi, so the pi stays in my answer. And at this point, I know that my lateral area is 60 pi square units. In this particular case, my units are inches, so I'm going to label that and call it done. The next part of this question asks us to find the surface area. And in order to do that, I'm going to take the lateral area that I just found. So that's the area of this curved part of my cone. But to find the total surface area, I also need to include the area of this circular base. To find the area of a circle, I'm going to use the formula pi times r squared. So the area of my circular base is going to be pi times 6 squared, or in other words, 36 pi. So now I have everything I need to go ahead and substitute into this formula. 60 pi for the lateral area plus 36 pi for the area of its circular base gives us a grand total of 96 pi square inches for the surface area of this figure. If it had told me to round to the nearest tenth or round to the nearest thousandth, I'd get my calculator out and I would multiply and round accordingly. But because nowhere in this question does it ask me to round, I'm going to leave my answer as an exact value. All right, if you have questions about this example, put a star next to example 1 right now so that you'll remember to ask me the next time that you return to class. And let's go ahead and look at the next example. This one also has to do with a right circular cone, but in this case they're telling us that the surface area of this cone is 90 pi square inches. They're also telling us that the area of its base is 25 square inches, and they're asking us to find the height of the cone. So they're asking us in this question to kind of work backwards. Since it talks about surface area in the problem, I'm going to start by writing down the formula for surface area. We find surface area by taking the lateral area and adding the area of one base. The problem is I'm not given any of the dimensions in this problem so that I can label my cone in any way, shape, or form. I'm not going to let that stop me. I know that the surface area is 90 pi. So in for surface area, I'm going to put 90 pi. I don't know the lateral area, but I do know that you find lateral area by multiplying pi times the radius times the slant height. So I'm going to change that lateral area to pi times the radius times the slant height. I don't know the radius, but I do know that the base has an area of 25 pi square inches. They tell us that in the problem. Now in looking what I've got when I'm done with my substituting, I'm noticing that all three of these terms all contain a pi. Just to make my problem a little bit nicer, I'm going to go divide each and every one of these terms by pi, because this will make my problem a little bit nicer to work with. It just makes everything a little bit simpler. I'm going to go ahead and subtract 25 from both sides. So the product of the radius and the slant height now must be 60. And at this point I'm in kind of I'm at a standstill because I don't know the radius. I don't know the slant height. I do know though that the area of its base was found by taking pi and multiplying it times r squared. And I do know that when that was done, the area of the base was found to be 25 pi. If I cross off a pi from both sides, I know that 25 is equal to the square of the radius, and that the radius must be equal to 5. So now I have that last little piece of the puzzle that I can come back over here and fill in. I now know that 60 is equal to the radius 5 times the slant height. And now I can solve and find that the slant height is 13. So I was able to use the information that was given to me in the problem to find out a lot of things about our cone. I found out that the radius of this base is 5, so I'm going to come label this over here in the picture. We were able to determine that the slant height of our cone was 13. I'm going to come and label that in the picture. What we really truly want to find, however, is we want to find the height of our cone. And now looking at our picture, we can see pretty nicely here that we have this little right triangle where we know that the length of the hypotenuse is 13. We know that the two legs are h and 5. We can go ahead now and set up a problem using the Pythagorean theorem that'll help us find the height of our cone. So when I square 5, we get 25. Square 13, you get 169. And this has us back on familiar territory. It's comfortable, it's easy. We find the height of our cone to be 12 inches. So one thing I want you to notice here is that this is a multi-step problem. You had to use the information that was given to you to go find the radius, to go find the slant height, and then once you know those two components of your cone, you could use those to find the height. So it wasn't a direct one-step process. We kind of had to use a circular route in order to get there. All right, this one too, if you have a question about it or there's something that doesn't feel right or make sense, would you please put a star next to it so that you can remember to ask about it the next time that you come back to class. All right, volume of a cone. Very similar to finding volume of a pyramid. In fact, it's the exact same formula. So let's not waste any time. Let's jump right in and get this done. This time we have a cone whose height is 6 feet. We know that the height is twice the length of the radius. So that tells us that the length of the radius must be 3. They want us to find the volume of the cone. So we find volume by taking 1/3, multiplying it times the area of the base, and then multiplying that times the height. So base is a circle. Formula for a circle is pi times r squared. So the area of our base, 9 pi. The height of our cone, and looking at the picture, 6. And now, again, I need to make that decision about what it is that I'm going to put in my calculator. In the question, nowhere do they use the word round. So my answer needs to be an exact answer, not a rounded answer. And because I need an exact answer, I'm going to keep pi in my answer. So I'm going to input all of those factors except for the pi. So I'm going to get my calculator and multiply 1/3 times 9 times 6, or in other words, 18. Because I have yet to multiply by the pi, that's going to appear in my answer. Volume is measured in cubic units. In this particular case, our units are feet. So our full and complete answer is 18 pi cubic feet. All right, this one too, if I said something that doesn't make sense or that doesn't feel comfortable, would you please put a star next to that so that you can remember to ask about it the next time that you come back to class. And in the meantime, we're going to jump right into this last one. This is kind of an intriguing example because unlike all the others that we've looked at so far today, this one they don't provide us with a picture. So to draw a cone, I'm going to start by drawing a circle. I'm going to draw the vertex. I'm going to connect that vertex to 2 points on my circle. And again, I'm not the most artistically inclined, as you all know, but even I can draw a picture of a nice little cone. So our cone has a radius of 9. I'm going to go label that in the picture. It has a volume of 675 pi cubic feet. They want us to find the height of our cone. We don't know the height. There's where it is in the picture. I'm going to call the height x. Now, they tell us that the volume of our cone is 675 pi. We know that they found that volume by taking 1/3 of the area of the base and multiplying it times the height. I'm going to go ahead now and substitute that 675 pi in for the volume. I don't know the area of the base, but since I do know the radius, I can find the area of that base. So the area of our circular base then is 81 pi times the height, which I called x. I'm looking at both sides. Again, I'm seeing that pi on both sides. I'm seeing a nice little way to clean this up. Just divide both sides by pi. I'm going to do 1/3 times 81 at the same time. 1/3 times 81 is 27. The pi's cancel, and I'm left with the x that I had here on the end. So now I've got 675 is equal to 27x. I can go ahead and divide both sides by 27. When I do that, I come out with a nice, neat, even value for the height of our cone. Height is measured in just plain old units. So the height of our cone has to be 25 centimeters. And I should identify somewhere on my paper that either X represents the height or that the height of our cone is 25 centimeters. This one too, folks, if you have a question about anything I said, or if there's anything about it that feels uncomfortable or not right, would you put a star next to it so that you can remember to ask about it the next time you come to class? So then the next time you come in, we'll be prepared to do some practice involving lateral area, surface area, and volume of our new friend, the cone.